Good morning or good afternoon, it's Miss Bauer again, and today we're going to pick up talking about kites and talking about trapezoids. So, kites and trapezoids are not parallelograms. So if we take a look at this kite right here, I'll notice in this kite that neither of the sides are parallel. So meaning that this side is not parallel to that side, and that side's not parallel to that side, therefore it's not a parallelogram. Now, a trapezoid has one set that's parallel, but not two sides, which means that none of the shapes that we're going to talk about today are parallelograms. So let's talk about trapezoids. Trapezoids have one pair of opposite sides that are parallel. These are what we call the bases. So I don't know if you've ever seen like B1 or B2, that's just talking about the bases. And the consecutive angles on the non-parallel sides are supplementary. So we sometimes call these the legs. And all that it's saying is that these two angles on the leg will add up to 180. And it's the same exact thing on the other side. Now, we don't know about the bases. Like, these are probably not going to add up to 180. It might be a fluke if they do, but it's the legs that add up to 180. So, for example, if I told you that, let's say that this angle up here is 50 degrees, and then let's say that this angle down here is 100 degrees. Well, it's the legs that I need to worry about. So 180 minus 50 would make this piece right here 130. And then to find this angle over here, I would do 180 minus 100 because the legs add up to 180, so then that would be 80 degrees. And that pretty much is the only pattern that we have for a trapezoid. Not a lot to know, but just that one pair of sides is parallel and the other sides are supplementary. Now, when isosceles trapezoid gets a little bit more specific, I still have my parallel sides. I still call those the base. But if it's isosceles, then the legs are congruent now. Now, because an isosceles trapezoid is a trapezoid, all of these rules still apply, meaning that the legs are still going to add up to 180. But because it's isosceles, because there's ticks here, it means that our base angles are going to be congruent as well. So this angle will be congruent to that angle. And down here, these base angles will be congruent to those base angles. Now, that's not necessarily the case with just a normal trapezoid. So like I don't necessarily know these aren't congruent, 50 and 80, 130 and 100. But in an isosceles trapezoid, they will be. So let's just say that I said that this angle right here is 50. Well, if it's isosceles, and I know that this is 50, I know this other base angle is also going to be 50. And then the trapezoid rule of the legs adding up to 180, 180 minus 50 would make these other ones 130. So isosceles trapezoids are symmetrical. I can pretty much cut them down the middle. Now, something else about isosceles trapezoids is that the diagonals are congruent. So if we know that this length is 10, well, we also know that this length right here is 10. And that would just be because if the legs are the same, it's like 8 and 8, and then the angles are the same, then our diagonals are going to be the same as well. So let's take a look at some problems with trapezoids. So if it's isosceles, that's a key thing to know. If it's isosceles, then remember that the lower two base angles are congruent, the upper two base angles are congruent, the diagonals are congruent. And in a trapezoid, remember that when this was 50, that one over there was 130, and it switched. So the trapezoid works out that the opposite angles are supplementary. Now, don't forget that you're allowed to use that colored piece of paper on your quizzes and on your test, and that you'll have all of these formulas and examples on there. So the other thing that we haven't talked about yet is we'll talk about medians, or sometimes called mid-segments of a trapezoid, and that's just taking the average of the bases to find that middle. And so this is a formula right here that you might want to copy over to your colored paper just so you have access to it. So taking a look, I know that this first shape is a trapezoid because I see these tiny, tiny little arrows showing that this base is parallel to that base. It's not isosceles, I don't have any ticks, which means that the only rule that I know is that the legs add up to 180, meaning that these two angles would add up to 180, and then on the other side, these two angles would add up to 180. So to set up this problem, I'm going to do part plus part equals 180 and go ahead and combine like terms. So 12x and 13x would be 25x. 2 and 3 would be plus 5 equals 180. And now I'm just going to solve for x. So subtract 5 on both sides. So 25x equals 175. And whenever you divide both sides by 25, you get that x is 7. Think like how many quarters in $1.75. Okay, now we didn't have to, but let's just say that it wanted us to plug it back in. So if we plug in 7 over here, 12 times 7 plus 3 would be 87. And if we ask ourselves what plus 87 would give us 180, well, that'd have to be 93. So we're going to check this. I'm going to give you a minute. Go to the calculator and do 13 times 7 plus 2. And if we're right, then we should get 93. Because these should be supplementary. They should add up to 180. And if you check it, it does actually work out. So 87 and 93. Now, if it were isosceles, we would know this other side, but we don't. So there's not much to do with it. Okay, now it says AB is 7y plus 6. So I have another trapezoid. So AB is 7y plus 6. I'm just going to label it and then see what it wants. E to F is 5y minus 3. And DC is y minus 2. Find the value of y. Now, this right here is called a median, or I call them mid-segments of a trapezoid. To figure out the middle of this trapezoid, I'm going to add the bases and divide it by 2. And that's what this formula says right here. To find the median, I'm going to add the bases and then half it. So I'm going to start by adding the bases. So I'm going to add my bases, combine like terms. So I end up with 8y plus 6 minus 2 is 4. I'm going to half that, and that's going to equal the middle part, which is 5y minus 3. Now from here, I've got a few options to solve. I can actually half this, like 8y plus 4 is pretty easy to divide by 2. But let's just say that I couldn't divide it by 2. Let's say that it was like 7y plus 37 or something weird. Well, the alternative is just to multiply the opposite side by 2. Because remember, whenever we're solving equations, we do opposites. So that's what I'm going to do. Instead of halving this, I'm going to multiply my other side by 2. So 8y plus 4 would equal 10y minus 6. So you can also think of the median as double the, so if I add the bases, the median's double. So kind of think of it the opposite direction. So taking a look, now that I'm here, if I start to solve, if I subtract 10y to put the letter on the left, 8y minus 10y would be negative 2y plus 4 equals negative 6. And then I subtract 4, so I have negative 2y equals negative 10. Well, that's okay, because I just need to remember that 2 negatives make a positive, so y would equal 5, and that's it. Now, I'm going to go quickly check this, because it should work out that if I plug it in, I add the bases, divide by 2, it should all work out. So y minus 2, 5 minus 2 would be 3. 7 times 5 is 35, plus 6 would be 41. And if I add 3 and 41, I get 44. Divide it by 2, which means that this piece right here should be 22. So 5 times 5 is 25 minus 3. So 25 minus 3 makes that 22, which means it works out. So that's our rule for medians, or sometimes called mid-segments. Now, trapezoid DONE, done, is an isosceles trapezoid. Now, the past two problems, we didn't know if they were isosceles or not. We're going to go ahead and assume that they're not. But on this problem, it tells us that it's isosceles. So as I'm reading, so it says angle EDO. So that full corner up there is 110. So angle EDO is 110 degrees. Okay. And then angle DEN, so DEN, that bottom corner, is 15x minus 5. Okay, now because this is isosceles, I can find a lot of values here. If angle D is 110 and this is isosceles, There's another angle that's 110, and that would be angle O. So like angle D would be 110, angle O would be 110. And then to find these ones down here, I have a few options. Remember that these should add up to be 180. So I could do part plus part equals 180. But I also know that this is 110. So if I do 180 minus 110, that's going to tell me what angle E is. So 180 minus 110 would be 70 degrees. And if angle E is 70, then angle N should also be 70 as well. Because it's isosceles, it is symmetrical because it's isosceles. So if I'm going to solve for x, I know 15x minus 5. Well, we just figured out that angle E is 70. So I'm going to say that 15x minus 5 equals 70. And that allows me to solve for x. I'm going to give you just a minute to see if you can solve that on your own. So I would start by adding the 5. Remember, we're trying to get x by itself, so I'm going to move everything else away. So if I add 5, 70 and 5 makes that 75. Divide both sides by 15, which would make x equal 5. And that's it. I would have gotten the same answer if I had done this plus this equals 180. So I would have still gotten that x was 5, even if I used the leg rule and added to 180. And then taking a look at our last trapezoid, it says trap is an isosceles trapezoid. So it's symmetrical. That means if I know angle T, I know angle R. I'm just making up numbers. Like if angle T is 30, angle R is 30, and then A would be 150 and P would be 150 because it's isosceles. Okay, it told me PR. So PR is 3x minus 7. And then it told me that TA equals 70. Well, there's a rule about the diagonals in 20, not 70, my bad. There's a rule about the diagonals of an isosceles trapezoid, and this is where this formula chart comes into place. I know that it's an isosceles trapezoid, so if I get stuck, I can look at the shape and then go look at my rules. And this last rule says that the diagonals are congruent. So if I go back, I knew that it was an isosceles trapezoid. It told me that the diagonals are congruent. Remember that congruent just means part equals part. So that's how I'm going to set this up. 3x minus 7 equals 20. And now I'm going to solve for x. So add 7 to both sides. So 3x equals 27. And then to get x, divide both sides by 3. So x equals 9. So remember, if you get stuck with the trapezoids, just remember that the legs add up to 180 always. And if it's isosceles, you have a few more rules that you can always go look up on your chart. We'll see you in just a bit to talk about kites.